So today and Friday we're just gonna keep playing around with these with ggplots. Alright, so I'm gonna keep working off of the same script that I started building on Monday. Right, I'm still gonna play with the iris data set for a little bit, because there are a couple other options that I really haven't messed with all that much, and some of them are really handy. So I just have my original scatter plot. So this is the first scatter plot that we made on Wednesday, just to kind of remind ourselves. I already installed or not installed, but I went ahead and loaded my library, my ggplot library. So let me just run this real quick. I don't necessarily, just to remind ourselves what this is what we're looking at. So this is just a test scatter plot between sepal width and sepal length. But we have more data in iris than just sepal length and sepal width. So let's see what else. We also have two other columns for petal length and petal width. So I'm gonna draw those out first. I'm just gonna change from sepal to petal and see what this graph looks like. Oh boy. Because I feel like, yeah, sepal width, or sorry, petal width is a little more discrete. It's a little different. It's a little more, I don't know the right word, different. I guess different, for lack of a better word, than the sepals. But, so we just have a general geom point graph going on here, right? This is just a simple scatter plot, x and y scatter plot. My x and y axes are a little bit off. That's okay. That's easy to change. Petal, just so I know everything's straight. Let's see. I'm gonna try to add another layer on top of this graph. So it's going to give me like slopes of the line, and also give me a kind of a distribution of the data points around that slope. I don't think that's all that hard to do, and I think I can do it with just I think I can do it with geom smooth, where method is equal to lm. It's just a linear model. I know this isn't a stats class, and we're not doing a whole lot of. I'm not really describing a whole lot of stats, but a linear model is just. It's a straight line calculated from data points. And so if I run this, it should. Let's see what happens. It should give me distributions around those points. Let's see if it's going to complain at me or not. Oh, yeah. Right, so now it gives me this line, the slope through the points, and data points around it. So we're getting the data points from geom point, and we're getting this smooth. We're getting kind of a distribution of these points, or at least a slope through all these points, or the best slope given these points, and also and maybe a standard deviation or a standard error, like an average distance from the line, from the slope. All right, so this is pretty nice to look at. I'm not gonna lie, this is quite pretty. But I'm going to take this one step further. So sometimes I don't necessarily like to have all of my points and all of my plots in one XY graph. Sometimes I want to parse these data points out by say species, right? I just want to look at individual species. Well, I can, with ggplot, I can create an individual graph for each species. So one of my favorite commands here is facet grid, FACT_grid. And so facet grid's a little bit uncomfortable to get introduced to, but nonetheless, the default way is basically I want to separate these data points based off the species, right? I want to give an individual graph for each species. I can do that one of two ways. I can either set the let's just play around with it. So I'm going to do, it's a weird way to do it, but it's going to be like the tilde. So this is the shift key under the escape. Tilde, say species. I'm going to get rid of scatter plot. I'm going to get rid of this so I can just run it and see it. And so let's see. This may complain. There's always a chance it'll complain. Facet grid. Let's see what's happening. Right. So what I've done is now I have this, again, it separates the data points based off of the species, but it keeps the same x and y axis, right? So the x-axis is still between 0 and 7, or 1 and 7. I'm not entirely sure. But now we have an individual plot for each species. And so I can make this go vertical, and I can also make it go horizontal. Sometimes it just depends on how you want it to look, right? So at this point, we're kind of getting into, I would definitely argue, kind of like artsy details. Because I think graphing plots is both, right? We want to present the data as well as we can. As easily observable as we can. So in that regards, it gets a little artistic about how we display our data. And so if we want to have this, basically all of these plots are on the same y-axis, we would do this tilde species. But say if we want to split on the x-axis so that we're going to have all of these points on the same x-axis, not necessarily the same y. It gets a little bit weird, but it's going to be species tilde period. And so that should put all of my points on an x-axis, so that the x-axis is static, but we have individual horizontal plots for each species. Again, it's just kind of how we want to display our data. Right? I think it's very much like painting. Like you want to make the best picture you can to convey your feelings or whatever, and it takes practice. But nonetheless, so if we're kind of summarizing facet grid, if we want it split on the x, split, basically it's going to be the category tilde period. Alternatively, if we want to split on the y, it's just going to be tilde category. But nonetheless, I use facet grid a lot. This is one of my most commonly used options to give me plots like so. So I'm going to leave that there, and I'm going to apply this facet grid concept to the density plot that we started with yesterday. So if I'm going to run this and kind of remind ourselves about what that density plot looked like. And right, so stuff overlaps with each other. It's not exactly the prettiest of graphs. Right, everything is split. A lot of stuff overlaps. So if I want to, say, isolate those plots or these histograms, I would use the facet grid. So again, I'm just going to basically use the same command, facet grid, and then I'll do tilde species, whatever that category is. You can so let's see how that looks. That looks okay. I think we split the opposite way. I think if we split on the y-axis, I think it'll look a little bit better than splitting on the x. Yeah, that looks a little bit better. Right, that's a little bit more informative. That tells us more about how these data points are related to each other among these species. Right, so again, it's kind of a guessing game. It's kind of a playing around game, and we just have to work at it until we get the shape or the plot that we want. Right, and so I'm going to get rid of, just for me, I'm going to get rid of this alpha that's causing this opacity. I'm going to get rid of that option. Right, because we don't need that opacity option anymore. Now we can just have our full colors for this plot. All right. So where do I want to go from here? We comfortable, or at least we see what facet grid is doing, or how we can have facet grid display our data in a very aesthetic and also informative way. What else can we do with this? So we haven't really talked about it, but we can also, I mean, the nice thing about ggplots is we can manipulate pretty much anything that we want. So I'm just going to reload this geom smooth thing. That's not a good example. I guess what I'm getting at is that we can control the x and y axes, so we can control how those are displayed. So, for example, we can control how wide we want our x and y axes to be with two commands. An xlim is going to set the base and the start and the end point of the x-axis. So, for example, if I want it set on 0 to 10, just for playing around, right? We're just playing around. This isn't what I do. I think the axes are fine. I wouldn't really play with this, but just to demonstrate that we can mess around with axes and where we have a start and where we have a stop, we can use xlim to do that. Same thing on using the y. We can do a ylim to do the same thing. Say set it equal to 0 and 5, right? So the y is just going to range from 0 to 5. And so that will change our plot a little bit. It's just going to add more, it's going to give us more white space, right? So we just changed our plots to mess around with our x-axis, to mess around with our y-axis, to basically have a custom range of data points, right? So we can use ggplot to control quite literally everything if we don't necessarily like how those, the default graph is. Kind of neat. And again, so if I'm going like kind of like going back to my early days of plotting around, I made a lot of Excel graphs whenever I started grad school because I hated R. I hated working in R. It really wasn't until like 2016 to 17 that I started playing with ggplots. And I wish I would have, if I could go back and do this again, I would definitely invest more time into ggplotting, right? Because if I'm doing this, right, I can keep my data in one space, have my script that's going to make my plot, and then save my plot and be done with it. And so I'm going to do an example kind of just like this, but I'm also going to introduce not exactly an R-friendly data frame to do so. So first of all, I'm going to save this, but I'm going to leave it here, but I'm also not going to, I'm going to be done with the script because it's messy. It has examples in it. So let's build a new script that's actually going to read a data frame, some of our own data. So I'm looking at, I think, vert.tes. I should have sent y'all vert.tes, and so that's what I'm going to be messing around with. So when I need to set my working directory, make sure I actually have that file in this test directory. Vert.tes, yes, I do have vert.tes. And so again, let me start a new script as well. I'm going to call it plot vert.tes. Of course, like any script, like any script that I start, when I'm going to comment it. So I'm going to make a bar graph here. We haven't made a bar graph yet, but this is another kind of common plot that we use, right? So I don't know if I'm necessarily going to really fancy plots where we're just using, scatter plots, box plots, bar plots, histograms, hopefully plots that are right internally manageable, right? This isn't necessarily new information. We've seen all these plots before and know what they're describing. That's what I'm making that assumption. So a difference so this file is a CSV file. So I've talked about uploading a comma delimited file. So if I'm looking at this, and just so we see it, let's see what happens. So recognize I inputted all this data into Excel. Some of this was by hand, some of it was summaries of scripts, whatever. And so this isn't an R-friendly data frame, and we'll kind of see that in a second. But what we have is the genome content, how many bases within each genome are from the major transposed by elements. How many are kind of like simple repeats or low complexity repeats, and then all of this single non-repetitive stuff. And so I have this for a whole bunch of different vertebrates. So I have a painted turtle, green anole. These are reptiles, birds, mammals, and fishes, right? So pretty much the diversity of vertebrate life. Now I'm just kind of showing this for a second. So I can inherently export CSV files from Excel. If we're unaware of that, CSV files are probably the way to go for R things because commas are kind of rare in data frames except as a delimiter. So just so we can see it, I'm going to go to Save As and just save as a CSV. right? I'm just going to save that as a CSV, and so whenever that does indeed get saved, yeah, that's fine. It's going to save it as a plain text file. So it is a plain text file that Excel can read, but other programs can also read it. So whenever I look at this file as plain text, right, all it is right, it's comma separated, right? So I have all of these commas, no white space, no white space in any of this, and all values are separated by commas. So this is the file that I'm going to be playing around with. I'm going to load in this specific CSV file. And I'm going to do that, not with read.table, but I'm going to do it as read.csv, because CSV is a little bit shorter of a command. All I have to do is define the file name and tell read CSV that there are headers here. Okay. And so that should load in this dat. Right, so now we have our data frame, where we have the, right, it basically looks the exact same thing, same way. Now, as I mentioned, this is not an R-happy data frame. We really can't graph this out very well. And we have to change the shape of this data frame. Again, we want each row to have independent observations, or a single observation. We want each row to display a single observation. But here we're having, we have like 11 or so observations. So this is, we have to melt this. We have to change how this looks. And so I can do that. I'm going to load in my library, ggplot. And I'm also going to load in a library I told y'all to install, and that's reshape. And so I'm going to start just sourcing this from the command line. So I'm just going to run the entire script from the command line, using my source and calling the R script, so plot vertex. All right, so that's going to load. It's just going to load reshape. It's going to load ggplot, and it's going to read that data frame. Okay, so I can use a function called melt from the reshape library. All columns into one row. Or sorry, all columns into like 1 or 2 columns. And maybe 3 columns. We'll see what happens. So I'm just gonna melt this data frame. So I'm gonna call it something different. I'm gonna call it dat_m. This is just traditionally I use a capital M to let me know this is a melted data set, but we're just gonna do melt dat. Save it, run it, source it on the command line, and we should see dat_m pop up. And so when we look at dat_m, let's see what that looks like. Okay, so now we have each row is a single data point, or is a single observation. So we know in lamprey, the species lamprey, for DNA transposons, there are X number of bases. That's one row. Lion and lamprey, that's one row. And so now we have a ggplot happy data frame. So we have all of our species observations into one column, all of the TE types into one column, and all of the base pairs for one column. Right, much easier. Right, we can work with this data set. And so before I realized that melt existed, I would do that by hand. I would go to the CSV file and physically move columns around so that all of these there's one row per observation. Hugely tedious, really annoying. Melt saves a lot of time. And so melt, we can define, just so we're clear about it, right? If we look at the actual melt help menu, oh, this is not helpful at all. I lied. Nope, not helpful. Not helpful at all. Scratching that all out. All right. So if we look at it, this does get a little tricky, and with our melted data frame, recognize like the column names do change, right? So we have an X variable and value. A little annoying, but we can still work with it. We can certainly still work with this. I can theoretically change the column names if I want to, but I also can just change my axes titles in ggplot also, so I'm not really concerned about it. All right, and so again, we're going to ggplot this out. And so I'm going to call the data frame, so that's dat_m is the data frame I care about. Set the AES, x equals, and y equals. And so I'm going to make a bar plot with this. So I'm going to make specifically a stacked bar plot. So it kind of looks like we get a breakdown of how much of a genome is made up of TEs. Right, because that's if there's one thing in the genome I like more than anything else, it's going to be a transposable element. So I'm going to set my x equal to, I want my x on the, I want my value as x. So what I'm going to do, I'm going to draw this out kind of where the species are on the y-axis and the counts are going to be on the x-axis. So it's going to be kind of a flipped bar plot. So I need to set that to value, and y is equal to variable. Again, these things I can change, right? And then I'm going to fill it by, it's going to be x. I'm going to fill it by TE. So I'm going to use this x, because that's just the name of the column. And so now I need to define what kind of plot I want to make. So this should be a geom bar. Oh, geom bar. Now geom bar gets a little tricky because there are a couple of options that don't make sense why they're there, but nonetheless they're there and we have to include them. One of those is stat equals identity, and so that should give us a stacked bar plot. So I'm going to run that. I'm going to run that in my terminal. Because if I try to run this script without like saving the ggplot or anything like that, if I just try to source this script, I'm not going to get that ggplot out, right? It won't display. I have to run that ggplot specifically in the terminal for that to run. Okay, and now we have the stacked bar plot where the base count is on the x. Species is on the y. I don't like those colors at all, and I certainly have manipulated these colors to make them look better. But this pink, I really hate this pink being used to occupy the single bases. But nonetheless, reading that CSV file, looking at base numbers, is a huge pain. It's a pain on the eyes. It's a pain to think about. So I don't like seeing tables of numbers. I would much rather see tables of numbers printed and plotted out, because now we can get an accurate comparison of both genome size and TE or repetitive content among all of these different vertebrate species. And so if we see a handful of trends, generally fishes have reasonably small genomes, like a lamprey. So this is 1 billion base pairs. 1e to the 9 is a billion base pairs. So lamprey has a much smaller genome than a billion base pairs. Stickleback is a really popular evolutionary model in fishes. and fugu is basically a blowfish, a pufferfish. It's a pufferfish. Not a lot of TEs in there, so really small genomes, no TEs. A coelacanth, so that's a lobe-finned fish. Reasonably sized genome, relatively few TEs. But if we look at the mammals, so we have bat, platypus, human, and mouse, much more TEs. Almost half of each genome is repetitive TE content. Neat. And so I can display this a couple of different ways. So this is a stacked bar plot, and this is what I would use for this specific case, because again, it tells me basically the cumulative number of bases to each genome and the composition of TEs to those bases, right? The composition of TEs in the genome. More things we can pull out of here. So like lines and LTRs. Definitely signs, lines, and LTRs are way more common in human genome. Line, signs, and LTRs. But DNA transposons, you're more likely going to see that in fishes, right? So amphibians, reptiles, and fishes, specifically like the zebrafish, has a lot of DNA transposons. So we both see genome size vary, and also the types of transposable elements present vary. Kind of neat. But let's pretend, this is pretending and we're just playing, that I don't necessarily like a stacked bar plot in this case. Maybe I would prefer like plots to be side by side. So instead of stacking it, position, let's see if I can do this. Position equals position dodge, I think. Again, just kind of a code. Let's see if that complains. Just kind of an option that you need to unstack a bar plot. So now that we start at the same point on the y-axis for each TE type, right? So this is why I wouldn't use this. This is an ugly graph. It tells me very little. It doesn't give me I don't think it gives me an accurate comparison of genome size and TE content. But sometimes we do want a stacked bar, this side-by-side bar plot. But nonetheless, if we're making a bar plot, we either have to so an unstacked is always going to be G on bar. Stacked equals identity. Identity is in quotes. Don't ask me why you need this. Don't know why these options are present. But unstacked, we have to also add that position equals that dodge equals position dodge. Again, don't know why that's there. It's just part of the ggplot code. It's necessary to make an unstacked bar plot. Here we go. Okay, so again, I don't like having this as a position dodge, right? I want this to be stacked. And I also want my options to be also want a black and white theme. Nice. That looks okay. I want to rename my x-axis, so I don't like x-axis, so I'm going to rename my x-axis xlab in quotes. I'm just going to say nucleotides. right? So that's going to get rid of label, replace nucleotides, and I have not touched this option at all. This theme option or this theme function. It really is just called theme. So instead of theme BW, we just have this full function called theme that we can define a bunch of parameters in here that will control how this plot looks. So for example, I don't want a title. I don't want my y-axis to have a title, right? I can look at these and know that these are different species, right? I don't need a y-axis title, so I can get rid of that with this theme option. I think it's going to be title, axis dot title dot y is equal to element blank. Again, just code that we have to recognize exists. Very poor reasons why that's there, but nonetheless it is, and so we have to deal with it. So that should get rid of the y-axis. So I'm going to put a comment here that theme controls plot appearance. And so we can do this for another one. So I don't like that the this X label here on my legend. So I can get rid of that as well. So within theme, we can have a bunch of different parameters that are specific to theme. So it's almost like ggplot is its own language, and even theme is its own language. But just like ggplot, I don't have to put all this stuff on one line. But I'm not going to use I can't use a plus sign either. So everything that I'm going to do is within the theme function. So in that case, I have to comma separate my different commands. So I'm going to get rid of that. So I'm going to put a comma at the end of element blank. And then legend, I think legend title, also going to set to element blank. And so recognize, so my parentheses are satisfied at this point. That's always going to be a struggle with R and anything like that is satisfying parentheses, commas, plus signs, etc. It's just an inherent struggle, but that should get rid of my my title, right? So that gets rid of my legend title. Theoretically, I can move my legend within the plot itself. I'm not going to. That's a little bit tricky. I can also change colors, but again, that's tricky. And so I'm just going to say that my plot is done at this point. So I have the plot that I want made. So I'm going to save this as te plot, and then gg save that whole plot. I'm going to look at my old ggplot gg save command to realize I forget what I'm doing. So I want the output file first. So vert te bar, and I'll say this is a PDF. That's te plot is the figure that I'm going to save. Device, I'm going to make a PDF within quotes. And recognize I can change like my how tall or wide I want this plot to be in. So I can set my width equal to, say, maybe I want this skinny. So I may set my width to 5 and my height to 10. This may look terrible. Height equals 10. It may complain at me. A little bit. But I'm going to save that entire plot. So I'm going to save this entire script, right? So it really is like I read in my input file. I do the plotting I want to do with that. I have to melt it, do the plotting I want, and then save that plot as a PDF. So I'm just going to save that script and source it. Okay, right, so nothing's going to pop up here. Nothing should pop here. What should appear is this PDF in my test2 working directory. Right, so there's my vert TE plot. Now let's see how hideous this looks. Yeah, pretty awful. Pretty awful. Too tall. Yeah, way too tall. So that might be something I play around with, my X and Y, or my height and width, to get it to be viewed comfortably. So I'm going to close that and redo this. Let's just let's do 8 by 10. Okay, and so it should redraw my PDF, and so that looks a little bit better. This 10, I'm making it too high. I'm definitely making it too high, too tall, too long. Theoretically, I can also manipulate the size of my text. So my X and Y text, I'm not going to, but I can. Let me try one more time. Let me just shrink this down one more time. Let's go 6 by 8. And it's getting better. That's all right. That's not terrible. Let me do one more. Let me try 6 by 6 and see how ugly that is, and then I'll leave it at that. Right, this is where it gets a little bit annoying because you have to open, close, open, close, open, close. Right, that's not bad. Right, that's something I would work with. That's perfectly fine that I would work with. So right, ggplotting. And so we'll do one more day of playing around with ggplots, and then we'll move on to something else, right? So again, partially of introducing this to you now is so that you can keep using this strategy throughout the semester. Right, you can keep using R to make plots for assignments or for your own work, right? Again, especially for grad students, if you have data in a table format, I would encourage you to play with it. Just see what you can graph out of it, right? Instead of having a number of tables, just see how you can play with your data and make pretty to read plots. All right, so I'm done for today. Any questions about anything or something I need to repeat before we log off? Okay. If there's nothing else, then I'm going to leave it at that, and I'll see y'all again on Friday.